Again, welcome to Principles of Epidemiology. In this lectures, we're going to learn how to compare disease frequencies. That's a part one, lecture number 3. Again, our previous lectures, we learned how to find the disease frequency, how to calculate it by finding the prevalence, incidence rate, or cumulative incidence. So again, in our previous lectures, we learned about disease frequency, counting cases of disease in a population at or over a specific time period. And this will help us to measure, again, by measuring the prevalence, cumulative incidence, and incidence rates. In these lectures, we are going to focus on the determinants. Thus, we are going to identify the preventative, curative, and causative factors by comparing the measures of disease frequency and calculating the measures of association. So here we are going to deal with finding the absolute values and also the relative or ratio values. So our learning objective, again, we are going to explain how to compare disease prevalence or incidence in 2 or more groups. Most of the time we are going to compare in 2 groups. For example, we have people who are exposed to risk factors and people who are not exposed. Example, we can do a studies and we want to know the effect of cigarette smoking. So we are going to get maybe 2 groups, those who smoke cigarettes and those who don't smoke cigarettes. And we are going to compare the 2. In this case, we can do a cohort studies, either by giving some control or intervention, and then we monitor the 2 groups, those who are smoking, those who are not smoking, and we see at the end of the time period for the studies what will be the effects. Also, we are going to define the reference group and also identify appropriate reference group from a study. And a study with more than 2 exposures, we have the dichotomous exposure, which is two exposures, true or false, etc. Also, we're going to explain the importance of using explicit definition of exposed and also unexposed groups. So comparison is the essence of epidemiology. By comparing 2 or more conditions together, we can know the effect of a specific exposure or risk factors. So here we say we compare measures of disease frequency, such as the prevalence, cumulative incidence, and also the incidence rates. Again, our previous lectures, we had a definition of what is a prevalence and what is incidence. So prevalence will be dealing with the proportion of people who have the problem, and incidence will be dealing with the new cases, then those who are over those who are at risk of getting. So how do we compare them? By exposure status. So that's a very good example and the most common exposure. So we have 2 groups. One is exposed to some risk and the other group are not exposed. So example here can be smokers versus non-smokers. Now, why do we compare them? Now here we say that if disease occurs more often or less often in one group than in the other group, then there's some association between the exposure and also the disease. So that's our main reason why we compare. For example, we may have a studies, we want to know if smoking causes lung cancer. So our exposure will be smoking, lung cancer again will be our disease. So I may get 2 groups, those who smoke and those who don't smoke. And I may do some studies, maybe a cohort study for some period of time. It can be 10, 20 years, monitor these 2 and see if smokers, majority of the smokers will get lung cancer, while non-smokers may not. Then there we can say, yes, there's an association between smoking and lung cancer. So here we say having a noxious exposure is associated with having a disease. And also having a beneficial exposure is associated with not having a disease. So again, the main goal of doing comparisons is again trying to find, or in this case, we're trying to establish if there's any association between an exposure and also an outcome. And again, we are going to learn more about association. It's not causation. Actually, we learn this in biostatistics. There may be an association between two variables, but there's no causation between them. And we have the concept of confounding variable or the locking variable. A very simple example, I will go very fast on this. If, for example, we know that in Florida during the summertime, there's a lot of shark attack because the water gets warm and most of the sharks come close to where people are swimming. So there is often a shark attack during the summer. But at the same time, in the summer also, there's an increase in ice cream sales. Now, we can say there's an association between ice cream sales and shark attack, but there's no causation between the two because we don't think if a person take ice cream or buy ice cream, he will get attacked by shark. Or if a person is attacked by shark, is going to buy an ice cream. There's no causation, but there's association. And most likely we have a third variable, which we normally refer to as confounding or locking variable, which in this case will be the weather. When the weather is very warm, both two sales of ice cream goes up, shark attack also goes up. So there may be a causation between the warm weather and shark attack, or the warm weather and ice cream sales. But there's no causation between shark attack and ice cream sales. So let's see some possible comparison here. And here we have some example here. So we have two type of group. One we call the index groups, those who are exposed, and also the comparison or reference group, those who are not exposed or unexposed. So the aspect of exposure can be any. Example, we have exposed condition here, which says that ever smoke cigarette. That means unexposed will be never smoke cigarette. And we can compare these two. We may have a duration, for example, those who smoke more or 10 years, 10 years or more, and those who smoke less than 10 years. We may also have the intensity. Those who never smoke, always their condition, duration is stay, they never smoke. Intensity, stay, they never smoke. The timing, stay, they never smoke. But for smokers, again, we have some people who don't smoke too much. We have some people who smoke lesser or more, or some people just started smoking less than 2 years ago. Maybe the chance of getting a lung cancer, you have to smoke for a long period of time, duration, maybe in years, 10 years, 20 years, 30 years. You cannot start smoking in a week and get a lung cancer. If you get a lung cancer within a week and you start smoking, that means most likely the cause of the lung cancer is not from the smoking, maybe other factors. So here we give example, ever smoking? Okay, if it's yes, how long, the duration, or the intensity, how many you smoke per day, hourly, and also the timing. Started smoking at a young age or at older age. So this will be again a possible comparisons, a very good example. Then we have another example. In this case, the BMI, which is the body mass index. We can do a comparison here by saying whether a person is underweight or is normal weight or overweight or obese. In terms of fruits and vegetables, we may have the highest quintile or 4, 3, 2, or the lowest. In terms of sun, are we exposed to it? Sun exposure, are we exposed to it? Very high or medium or low, or maybe not at all, not exposed. Also, family history of breast cancer. There can be a comparison, first degree relative First degree relative will be, again, your immediate parents, or second degree relative, your parents, sisters, or brothers, aunt, example, or no relatives with breast cancer. So again, these are some few examples again about comparisons that we can make. And in this course, we are going to use the term index group as those who are exposed, and then comparison or reference group for those who are not exposed or they are less exposed. So let's start with the measurements. As we said earlier, comparisons of disease, the main thing we want to find the association. So normally, we always start with association before causation. Sometimes we may have association between exposure and outcome, but we may not have causation between the exposure and outcome. But anytime we have a causation between exposure and outcome, that means we have association also. So we start with measures of association. Here we say the measures of association is the comparisons of measures of disease frequency. So two approaches we can use here. The first one is the absolute measure. The second one is relative measure. We know in college algebra, when we talk about relative, the first thing that comes to our mind will be ratio. So relative measure is the calculate the ratio of two measures of disease frequency. Again, we will go through the steps. And also absolute measure is the difference. So we calculate the difference between two measures of disease frequency. Now, if the difference is 0, it means there's no any difference between the two measures of disease frequency. They all carry the same. Ratios should be 1. If the ratio is 1, that means there's no any difference between the two groups or two measures of disease frequency. So we start with other absolute versus the relative measures. Here we say, example, you are running late for class and you got stopped by a police officer because you are driving 60 miles per hour in a 30 miles per hour zone. Now the question is, this means we are overspeeding over almost 30 double. Now the question is, how would the police officer describe your offense using absolute terms? Or how would the police officer describe your offense using relative terms? So here we say that you were driving 30 miles per hour over the speed limit. Now, in this case, we are finding the difference. The difference. So this will be absolute. The difference, 60 minus 30 is 30. Now with relative, we are looking for a ratio. So here we say you were driving twice the speed limit. So again, this will give us some idea of what is absolute, what is relative. As we said previously, absolute will be difference of something. Relative will be the ratio of something, two things. Difference of two things for absolute, difference of two things for relative. So here I have two different speed. If I want to find the absolute, it will be 60 minus 30. So I will say 30 miles per hour over speed. Now, if I want to find the relative, it will be ratio. 60 divided by 30 will give me 2. So I'll say twice the speed. So again, that's the main concept. Now we will go details with the formulas. So the absolute measures of association, we start with the prevalence. Prevalence difference. Remember, we have two things. We are doing, this is comparison of disease frequency. So we have two groups, maybe exposed and unexposed. Some of the subjects that are exposed, the number of them who have the problem, the frequency. Some of the subjects who are not exposed, maybe some of them may have the problem. So we count the frequency of both two groups. So here we said the difference, prevalence difference is the difference in prevalence between the index and also the comparison groups. Again, the index are the exposed group, and comparison groups are those who are not exposed. So here we are using PE. So PE stands for the prevalence for exposed, and PU stands for the prevalence of not exposed or unexposed. Finding the prevalent difference, there's no units because we have proportion minus proportion or percentage minus percentage. So again, that's the prevalent difference. Here we are doing the absolute measure. Now let's go through the cumulative incidence. So cumulative incidence, we are trying to find the risk differences. So the difference in cumulative incidence between the index and comparison groups. So RD here stands for relative difference, which will be the cumulative incidence of the exposed group minus cumulative incidence of the unexposed group. Also, this is an absolute measures for cumulative incidence. Then the last one will be the incidence rate. So incidence rate is the difference in incidence rate. We are going to look for rate difference. Rate difference is the difference in incident rate between index and also the comparison groups. As we said earlier, the index are the exposed group, comparison groups are the unexposed group. So the rate difference will be incidence rate of the exposed group minus incidence rate of the unexposed group. So in our previous lectures, we already went through how to find the prevalence, cumulative incidence, and also incidence rates. So here we're doing comparison for absolute measures of association. This means we find the prevalence for exposed group, the prevalence for unexposed group. Then we find the difference of the two, which will give us prevalence difference. This will tell us if the risk factor really have anything to do with the outcome or the disease. So if my prevalence difference is 0, that means the exposure doesn't have anything to do with the disease, because the number of frequency we have with those who are exposed and those who are not exposed is the same. So anytime any of our prevalence difference, risk difference, rate difference, anytime the values are close to 0 or they are 0, that means that risk factor doesn't have much association, or it has a very weak association with the disease. So yeah, we said if there's no association between the exposure and the disease, then the difference here, RD, will give us 0. Same thing, if the exposure is associated with increased risk, so we are going to get a positive value. So our answer will be greater than 0. Now, if the association rather depress the disease, then we get a decreased risk, which means our RD will be less than 0. So we have example here, absolute measures of association practice. Here we have a nurses health study. Here we say this is a cohort study of the factors that influence women's health. So here we have the nurses health study, or NHS researchers investigated the hypothesis that hypertension increased the risk of myocardial infarction, which is MI. So here we want to know if hypertension will increase the risk of getting MI. So among 13,422 women with hypertension, 117 had an MI over 10 years of follow-up. And also among 106,541 women without hypertension, 125 had MI during the same follow-up. So you can see here we want to do a comparison. Women with hypertension and women without hypertension. And we want to know the myocardial infarction results among the two. So here we say based on this information, Which type of absolute difference measures can we calculate? So here we can calculate the risk difference. The risk difference. Remember the risk difference. We go back one more time. Risk difference will be the difference in cumulative incidence between the exposed and also unexposed group. Because there's if we do risk rate difference, we have to go with person time unit. Here, they didn't give us any time period. There's no any time period. So we cannot do rate difference, but we can do risk difference. Now, here we say, what is the risk difference among 13,422 women with hypertension and 117 had an MI over 10 years of follow-up? Also, among 106,541 women without hypertension, but 125 had MI during the same follow-up. So the risk difference again will be the difference in cumulative incidence between exposed group and also unexposed group. Exposed group will be women with hypertension. They are exposed to hypertension. And then the comparison group or unexposed group will be the women without hypertension. So here we can say the cumulative incidence in exposed women minus cumulative incidence. Again, CI stands for cumulative incidence in unexposed women. So to find the cumulative incidence, it will be 117 cases. We have 117 cases. And the total women with the hypertension, which is the exposed women, is 13,422. Then we have 106,541 women who are not exposed, but 125 have the problem. So it will be 125 divided by 106,541. So when we divide the two expressions, we get 0.0087 minus 0.0012. The difference here will give us 0.0075. So we can say it will be 0.75% risk difference, or we can say 75 by 10,000. So we take the points away over 10-year period of follow-up. And that will be the risk difference. So the risk difference in this case is very small. Now we also can use what we call the 2x2 table. And here we can also use the concept of the prevalence and cumulative incident data. So we can see the 2x2 table is the example we just did right now. We have those who have the disease, those who don't have the disease. From this value, we can know those who don't have the disease, because if 13,422 and only 117 have the disease, then 13,422 minus 117 will give me the women who don't have the MI or myocardial infarction. Same thing apply to 106, 541, those who are not exposed. I will subtract it minus 125, and that will give me the people who are not, the women who are not exposed, and also they don't have the problem. So that's will take us to 2x2 table. So we have those who have the disease, those who don't have the disease, as I said, like subtracting the total women minus those who have, will give me those who don't have the disease for both exposed and unexposed. So A plus C means the total of the people, or in this case, let's say the women, the total of women who have the problem, both those who are exposed and those who are not exposed. Those who are not exposed is C. They have the problem, they have the disease, but they are not exposed. A, they are exposed and they have the disease. Then B and D, B will be those who are exposed, but they don't have the disease. And D will give us those again, who are not exposed, and also they don't have the disease. So we can say the correct value we want to know is AD, because A means you are exposed and you have it. D means you are not exposed and you don't have it. So B plus D will be the total of women for both exposed and not exposed, and they don't have the disease. A plus B will be the total of the women who are exposed. C plus D will be the total of the women who are not exposed. So A plus B plus C plus D will give us the total people, both for the exposed and unexposed. So another way we can do this is also the same concept, but you can see here we have disease and no disease, then exposed and unexposed. We also have disease and no disease. So we are bringing the disease and no disease to the left, then exposed and unexposed to the column. So disease and no disease will be the row now, and exposed or unexposed will be the columns. It's the same. Again, sometimes we may say those who are the disease or no disease can be rows and the column, but the concept is the same. So here we say the choice of the table is up to you. The goal, you must understand what the table is doing. So here we can see here the table here is telling us how many people are exposed and they have the disease, how many people are exposed and they don't have the disease. That's B. C is telling us how many people are not exposed but they have the disease. And D is telling us how many people are not exposed and they don't have the disease. So D here is the same as the D. We have no disease, you are not exposed, so it's the same. A also is the same. Exposed disease, exposed disease. So again, it's up to you. So here we have the disease, no disease, A and C. And also another way we can again change the rows and columns, we get the same answer. So now we are going to use the 2x2 table to solve our previous problem. So here we say among 13,422 women with hypertension, 117 had an MI over 10 years. And also among 106,541 women without hypertension, 125 had an MI over 10 years. So we will come with our table. You are supposed to have the disease is 117. So here we have to identify the exposure and disease. So this is our hypertension, that's the exposed. Unexposed means you don't have hypertension. Again, the disease will be MI and no MI. So exposed and you have the disease will be 117. So we're going to fill in the tables, cells, and margins. So we know the total of exposed is given to us to be 13,422. The total of unexposed is 106,541. But those who have the disease is 117. So now we are going to subtract 117 from 13,422, and that will give us 13,305. These are the people who have the problem, but those who are exposed, but they don't have the problem. So 13,305 means you are exposed, you have hypertension, but you don't have the disease, the MI. 117 was what is given to us. They say out of 13,422, 117 have MI. So exposed have MI. Next, we have 106,541. That is the total of women who don't have hypertension. So they are not exposed, unexposed. But we have 125 have the disease. So we subtract 125 from 106,541. We get those who are not exposed, that means they don't have no hypertension. Also, they don't have no MI. So when we fill out the table in this way, we can also be able to find our incidence or the association between the two. So now we have the total disease is 242. Those who have the disease, total of people who don't have the disease, we had all the two, 119,721. And also the total together is 119,963. So if you add these two, you get the same value. If you add it across, you get the same value. So the total participants. So let's move forward. So now we're going to use the table for our calculations as we did it previously without the table. So if I want to find the cumulative incidence, remember cumulative incidence for those who are exposed, it will be 13,422 divided by 117. We can also find the cumulative incidence for those who are not exposed. It will be 106,541 by 125. And this will find the difference. So that will give us the risk difference. And we get the same value again. 75 by 10,000 over 10-year period. And we look for the risk difference, 0.0087 by 0.0012 minus, we get the answer. So next is we're going to interpret the absolute measures of association. Here we say the risk difference is again the difference comparison of prevalence, risk, rate of disease in the exposed group to the prevalence or risk or rate of disease in the unexposed group. Again, we are doing comparison to measure the association between two groups. So here the risk difference we find previously, we have 75,000 by 10,000. Now, women with hypertension had, this means the women with hypertension had 75 more MIs per 10,000 women over 10-year period comparing to women without hypertension. Because we can see even the decimal value, we can see that those with the hypertension, the cumulative incidence is a little bit greater than those with no hypertension. The cumulative incidence is less. So the difference of the two, if the difference is negative, that means the risk factor doesn't have anything to do with the outcome, or in this case, disease. So since we still have positive, it means that the cumulative incidence of those who are exposed is greater than the cumulative incidence for those who are not exposed. But in this case, again, the difference was small. But still, we say that 75 by 10,000 means women with the hypertension or they are exposed, they have 75 more MI per 10,000 women over 10 period comparing to women without the hypertension. So the important thing here, we should focus on the excess disease in the exposed group. And also we can specify the comparison group. And also we should specify the time period, in this case, 10-year period. So now we are moving, we finish with absolute measurement. Now we are going to do the relative measures. So relative measures of association will go with the rate or ratios, ratios. So here we can see the same prevalence ratios. Prevalence difference means the prevalence of exposed minus the prevalence of the unexposed. Now prevalence ratio will be prevalence of those who are exposed divided by prevalence of those who are not exposed. Then the risk difference, if you remember, we find the difference of the cumulative incidence of those who are exposed and those who are not exposed. Now, risk ratio is the same concept, cumulative incidence for those who are exposed divided by cumulative incidence for those who are not exposed or unexposed group. Then we also have the rate ratio, which will be the ratio of incidence rate between the index, which is those who are exposed, and also the comparison group, those who are not exposed. So relative risk is normally a generic term that we use to represent all of the classes of relative measures of association. And the goal of this comparison idea is to find the association between two or more groups. So relative risk is often used interchangeable with relative risk ratio, but again, they are the same concept. Risk ratio is cumulative incidence ratio because that is again the most common used relative measure of association. And here we say also it's often up to you to interpret which measures is being used, whether prevalence ratio, risk ratio, or rate ratio. So now relative measures of association, we say if there's no association, it should be one because we are dividing. In the absolute, it should be zero because we are finding the difference between the two. Now, if the exposure is associated with increasing risk, then our value will be greater than one. If it's a decreasing risk, then it will be less than one, which means if we are exposed to whatever, let's say we are exposed to cigarette smoking, the chance of getting lung cancer is low. Yeah, so now let's say the example here, which is almost same as the previous example, but this time instead of doing absolute measures, we are going to use relative measures. So the Nurses Health Study, again, they did a cohort study of factors that will influence women's health. And the Nurses Health Study researchers investigated the hypothesis that hypertension increases the risk of myocardial infarction. So the hypothesis is that when you have a high blood pressure, the chance of getting MI is very high. It will increase. So among 13,422 women with hypertension, 117 had an MI over 10 years of follow-up. And also among 106,541 women without hypertension, 125 had an MI during the same follow-up. So in our previous question, we saw that they say if we are, the conclusion we came when we are measure the absolute, we are using the absolute measures for the association, we came to base the same figure, the same values we have here. We said the chance of those who are exposed, that means the women that have hypertension, they are 75 more per 10,000 population to have the problem, MI, than those who are not exposed. We did, again, the absolute. Now, let's see if relative also will give us the same answer. First of all, they tell us what measurement we are going to use based on this information. And of course, that will be the risk ratio. Remember, we use the risk difference as before. So now we want to do the same calculation. What is the risk ratio? So among 13,422 women with hypertension, 117 had MI over 10 years of follow-up. And also among 106,541 women without hypertension, 125 had an MI during the same follow-up period. So the risk ratio will be the cumulative incidence of the exposed divided by cumulative incidence of the unexposed. And now we have 117 by 13,422. That will give us cumulative incidence for exposed. It's the same value we get when we're doing the absolute measures. And also for cumulative incidence for unexposed, the same value we get. Previously, we get 0.00872 minus when we are doing absolute. This time when we divide, we got 7.45. So in conclusion, again, we're going to interpret soon. Now we are using the 2 by 2 table. We have the same values, everything the same. Those who have the disease, they are exposed 117. Those who are exposed but they don't have the disease, since the total is 13,422, we subtract 117 from it, and we get 13,305. Same thing applies. Those who are not exposed, total is 106,541, and 125 have the disease, which is the MI. So we subtract 125 from 106,541, and we get 106,416. The total here is those who have the disease, both exposed and not exposed, 242. The total here is those who don't have the disease, but they are exposed and they are not exposed. And 119,963 will give us the total women altogether in the studies. So we are going to use the table. Again, we get the same value. We find the cumulative incidence for exposed. Then we find for the not exposed. This is what we did previously for the, again, RD means the risk difference. So this is what we have. Now, when we are doing ratio, you see that we divide the two values, the same cumulative incidence for exposed divided by cumulative incidence for not exposed. We get 7.45. So now we interpret risk difference as those who are exposed 75 more per 10,000 population may have the problem than those who are not exposed. Now, let's see how we're going to interpret the risk ratio. And that's the next question. Interpret the relative measure of association. So we say the relative risk is the ratio comparison of prevalence, risk, rate of disease in the exposed group to the prevalence, risk, rate of disease in unexposed group. So if our relative risk is equal to 7.5, then we mean to say that women with hypertension, again, if the value is greater than 1, it means the exposed is stronger, have an effect on the disease. So by this time, this will be 7.45 times as likely to have MI over 10-year period. Remember the example we did with the speed of a car. We have a police stop a person is driving 60 miles per hour and the speed limit is 30. If I'm going to use absolute measure, I'll find the difference. So I'll say 60 minus 30. The person is driving 30 more, 30 miles per hour more than required. But if I'm going to find the ratio or I'm going to find the relative measures, I would rather divide the 60 by 30. So instead of saying 30 miles per hour more, I will say 2 times more. And that's the whole concept here also. Now here, since we get 7.45 for the relative risk, this is again for relative measures. We will say that is 7.45 times more likely to have MI if you are exposed. So we also have what we call the excessive relative risk, which will be relative risks. So we need to find the relative risk first, then minus 1 times 100%. So in this question, if relative risk is 7.45, we say that women with hypertension had 745% increased risk of having an MI compared with women without hypertension. So what is the excess relative risk? If relative risk is 1.0, 2.0, 1.6, or 0.5. So in this case, 1.0 means excess relative risk is 0. Remember, it's a ratio. So if I divide two things and my answer is 1, it means they are the same. What we divide for the numerator and the denominator are the same. This will mean 2 twice, so 100% more. and 1.6 will mean 60%, and then this will decrease down. So this will mean again negative 50% or reduced by 50% because it's less than 1, so it's reduced. So what are the two ways to interpret an incidence rate ratio of 1.2? Here we say the exposed group has 1.2 times the incidence rate of the unexposed group because it's 1.2. Or we can say the exposed group has, see 1.2 means the extra is 0.2. So that will be 20%. 0.2 is the same as 20%. So we can also say the exposed group has 20% excess incidence rate as comparing to unexposed group. First, we say 1.2 times the incidence rate because 1.2, or 20% excess because 1.2 is 20% excess incidence rate as compared to the unexposed. Also here we say, what are the two ways to interpret an incidence rate ratio of 3.0? So the same concept, 3.0 times more. Or we can say that since this is 3.0, it will be 200%. So the exposed group has 200% excess incidence rates. And the next one, what are the two ways to interpret the incidence rate? So this reduce, at least if it's 1, it means it's equal, more than 1, more. But this time we are going to get a negative. So this is trying to say reduce. So the exposed group has 0.57 times, which means it goes down than the unexposed group. Or we can say 1 minus 0.57 will give me 0.43, which will be 43%. So 43% decrease. The exposed group has 43% decrease incident rate as compared to the unexposed group. So again, this section really teaches how to interpret our results when we get our relative risk value. So what's the difference between the two? Should I use relative difference, which is the absolute measure, or should I use the risk difference? RD stands for risk difference for the absolute measure of the association, or should I use the relative risk, which is again the risk ratio? Should I use the risk ratio for relative again measurement? So here we say the RD and RR provide different information and different perspectives. So with the RD, we are doing absolute measure. With the RR or risk, relative risk, we are doing relative measure. Risk difference, we are doing absolute measure. So we say RD will represent the measure of public health impact of exposure on the disease occurrence. For example, how much impact will prevention have, or how many people have determinate effect of a harmful exposure. Now with the RR, it will represent the strength or the magnitude. So it's a ratio. So the strength and the magnitude of the association between the exposure and the disease. This is more commonly used for etiologic research. Etiologic research is trying to find the causes or the strength of the causes of a disease. So how much more likely are exposed person to develop the disease? So we can see the difference. Again, we can use both to measure our association, both absolute or relative, but everything depends on the objective of your studies. Now, if I want to know how much likely the exposed people may have the problem, the disease, than unexposed, then I'll do relative measures. But if I want to know the impact, we'll see how many people have determined effect of harmful exposure. I want to know the impact. Then I will do relative again. I will do the absolute measure, which is the risk difference. So here we have two examples. Is smoking associated with death from lung cancer? And there's annual mortality rate saying we have 100,000 cumulative incidents. The study we did, cigarette smokers were 140, non-smokers is 10. Here we say smoking associated with death from coronary heart disease. We did the studies with cigarette smokers 669, non-smokers is 413. Now, we don't have all the data here, but we just want to use this as some measure. So if here we do the relative risk, and we get, or the risk ratio. Sometimes again, some books use the term relative risk, some books use the term risk ratio. So if the risk ratio is 14 and the risk difference is 130 per 100,000, we can see 14 is very strong. This means cigarette really have effect 14 times more to lung cancer. 130 per 100,000 may have it. So we can see that the RD or the absolute measure will tell us the specific number of people that may have the problem, the number of people that's more or less comparing with exposure and not exposure. But with the relative measures, it will give us some percentage or times. The same thing apply with the second one if smoking also related to coronary heart disease. We have 1.6, which is again is true, kind of not to comparing to 14. So 1.6 more times. Or we say 256 more people per 100,000 may have the coronary heart disease if they smoke. So here we say smoking is stronger risk factor for the first one, lung cancer. Also, smoking is a bigger problem, public health problem. So that will be the end of our lectures. Again, we will soon start with the part two of these lectures, which is again comparing disease frequency. So again, wish everybody the best and thank you.